We are doing lesson 15.3 today, which is all about tangents to circles. So the essential question, just a reminder that the essential question is always on your assignment sheet if you want to get that set up in advance. But the essential question today is, what are the key theorems about tangents to a circle? And feel free to pause the video while you get that down, but I'm going to go ahead and move right along. So first we need to know what a tangent is. So to begin, we're going to draw a circle, and I have this nifty tool called the geometer, and it has lots of shapes, and I'm going to use that to draw a circle here. Here, let me use this one. And if you don't have a tool like this, then you could think about getting one, or you could look for something else to use, some other circle stencil, or you can just freehand it. So there we have a lovely circle, and the cool thing about this is it has this other tool that will allow me to find the exact center. So if you don't have this, then you're going to draw a circle and do your very best to find the center of the circle and label it C for center. So that's a circle, which we've been exploring, but we want to talk today about a tangent. So a tangent is a line that touches the circle in exactly one place. So it doesn't matter where, it could touch the circle anywhere. I'm going to put a point right there, and I'm going to attempt to draw a line that goes through that point but does not touch the circle anywhere else, because we know that if it goes through the circle like that, that's a chord. So we're not going to draw a chord. We are going to draw a tangent. So it's going to go right about there. And it's important that you practice with a straight edge, drawing a tangent line to the circle. So you can see that it only touches the circle in that one point. This line is called a tangent. So please label that. And this point right here is called the point of tangency. Tangent line is a line that hits a circle exactly one time. So there are a couple of cool things about circles and tangents. The first, we're going to draw another circle and another tangent line. So again, just do your best if you don't have a stencil. There's the circle. There's the center. It's always a good idea to label that with a C. And I'm going to draw another tangent line. This time I'm going to draw my point of tangency right about there, just for variety. So first, kind of imagine what direction is this tangent line going to go. If it can't go through the circle at all, it just needs to sort of touch it right there. We're going to put it right like that. Tangent, point of tangency, circle, center. So I want you to imagine what would happen if we were to draw a radius of this circle that hits the point of tangency. In fact, we're not going to imagine it, we're just going to do it. So we're going to draw a radius of the circle that goes from the center to the point of tangency. There we go. So there's a theorem called the tangent radius theorem that says this is always a 90-degree angle. Okay? The radius and the tangent are always perpendicular. And of course, because this is a straight line, it's going to form two 90-degree angles, there and there. So we're going to go ahead and write down this theorem. It's called the tangent radius theorem. And you should feel free to write the theorem down in your own words if that's useful for you, but I'm going to go ahead and write down what the book says. So the book says, well, no, I'm going to abbreviate it. A tangent is always, that symbol means perpendicular, which means hits at a 90-degree angle. So a tangent is always perpendicular to a radius that hits the point of tangency. Okay, so take a minute and copy that down. A tangent is always perpendicular to a radius that hits the point of tangency. And the converse of this is always true. If you have a radius that hits a line at a 90-degree angle, then you can be sure that line is a tangent line. So we're going to do a couple of examples using this theorem. So example one, actually maybe we'll just do one example. Example one, once again, I want you to do the best that you can to draw a nice circle. Here's mine. I'm going to do my best to draw the center. Okay, there it is. And I'm going to draw a tangent line. So there's the point of tangency. We'll draw the tangent line. Tangent line, and we'll label this with a C. And then I also want you to draw in the radius that connects the center to the point of tangency. So that's the setup. And then we're going to write a couple of little facts over here to the side. First thing we're going to write is that the diameter equals 8 centimeters. So the diameter of that circle is 8 centimeters. We're going to add a point here on the line of tangency, and this distance between the point of tangency and this point we're going to say is 3 centimeters. We'll call this point A. And I want to know what is the length of line segment AC. So that line segment is not drawn in, so feel free to take a moment and go ahead and draw that in. But we're looking for what is the distance between A to C. And believe it or not, we have enough information. So I'm going to draw that line segment in. There it is. So going back to this theorem, we need to think about what do we know? We've got a radius and we have a line of tangency, and they both hit at that point of tangency. So what we know from this theorem is that this is a right angle. And if at this point you feel like you can finish this problem on your own, feel free to try it, and then you can pause the video, try it, and then watch the video and see if you got it right. So that's a great strategy if you think you know what to do. So we're looking for this line. I'm going to go ahead and put like a little question mark so that I know what I'm going for here. And then the other piece of information that I need to label is that the diameter of the circle is 8 centimeters. And that's kind of a trick because the diameter is not shown. But if the diameter is 8 centimeters, then hopefully we can figure out the radius. If the diameter is 8 centimeters, the radius is always half of that. So the radius here would be 4 centimeters. So I now have 2 side lengths of a right triangle. And if you're thinking of the Pythagorean theorem, then good for you, because whenever we know 2 side lengths of a right triangle, we can always use the Pythagorean theorem to find the third side length. This yellow line that I drew is the longest side of this triangle. It's the hypotenuse because it's across from the right angle right here. So that means when I use the Pythagorean theorem, a squared plus b squared equals c squared, I want to make sure that I use c as my kind of mystery because this is the one I don't know and it's the hypotenuse. So I'm going to go ahead and plug into the Pythagorean theorem. 3 squared plus 4 squared equals c squared, and we will simplify and solve. 3 squared is 9, 4 squared is 16. Drop everything down. By the way, if I'm going too fast, feel free to pause. 9 plus 16 is 25. And then to finish this up, we're going to need to take the square root of both sides. So square root the left, square root the right, and the square root of 25 is 5. So I now know that that line segment is 5 centimeters long. Okay, just a couple more things for us to talk about in this lesson. So we're going to go back and talk about a little bit more vocabulary, and I need you to draw yet another circle. And again, you need a center for that circle. Okay. We are going to talk about a circumscribed angle, and I'll write that down for you in a minute. But a circumscribed angle is formed like this. You're going to create two tangents anywhere on the circle. So I'm going to do a point of tangency there, and I'm going to use my yellow marker to kind of do this lightly, and I'm going to draw a tangent line like so. And then I'm going to pick a point of tangency somewhere else along the circle. So I'll put it here. Now wherever you do it, your two tangent lines will meet somewhere. They're either going to meet on this side of the circle, or if I picked a point here, they would meet somewhere else, but they'll always meet. So I'm going to go ahead and draw in this tangent line as well. Looks something like this. And you can see that they meet. The angle, the inside angle where they meet, is called the circumscribed angle. So what I'm going to do is come back with a solid line, and I'm going to really highlight that angle. So I've got that portion of that tangent line, and I've got this portion of that tangent line, and this angle that's formed is the circumscribed angle. So there are a couple of interesting things about circumscribed angles. The first thing that you should know is that these two lines' segments from here to here and from here to here are congruent. If we draw in these radii, I guess I'll use the same color. If I draw these radii in, this shape that's formed, this quadrilateral that's formed, should be kind of familiar to you, because obviously if this is a radius and this is a radius, those are congruent. So what we have here are two sets of congruent consecutive sides, and I don't know if you remember, but that is called a kite. So whenever you have a situation like this, a kite is formed. And kites have a lot of cool properties, but this is not just a regular kite, it's a special kite where both of these opposite angles are right angles. Why is that? Well, it's because of the tangent radius theorem. So we have an interesting kite. These two sides are congruent, these two sides are congruent, and these opposite angles are right angles. And I don't know if you remember this from when we talked about kites, but you always have one pair of opposite angles that's congruent, and the other pair of opposite angles is always going to be supplementary. So I think, why don't we number these angles? We're going to call this angle 1, and we're going to call this angle 2. And what's important for you to know is that angle 1 plus angle 2 will always equal 180 degrees. And there's a theorem. We need to write it down. It's called the circumscribed angle theorem. And it states that a circumscribed angle and its central angle can you see that? There we go. Are supplementary. So all that's saying is this circumscribed angle and this central angle, angle 1, they are supplementary. And the reason is because we have a kite here. So we're just going to do one quick example. I think I need another paper here. And then we'll be done with notes. We'll call this example 2. So once again, last time I promise, draw a circle, find the center. You're just estimating where the center goes if you don't have this cool tool. And we are going to draw two tangent lines, one about there, one about there. And we're going to draw the circumscribed angle that's formed by these. So the way I'm going to do that is I'm going to kind of find where my tangent line goes, and just really lightly. So if you're working with a pencil, just work kind of lightly. So one tangent line goes there, one tangent line goes about there, and figure out where they meet. And then go ahead and create that circumscribed angle just a little bit darker with your pencil, or if you want to use a different color like I am, that's fine too. Okay, circumscribed angle. And then we're also going to create the radii. One radius there, one radius there. So we're going to label this up with some information. We're going to say this circumscribed angle is x degrees. Ooh, that is hard to see. Hold on. Okay, x degrees. And we're going to say this is 100 degrees. This radius here is 4 inches. And this length here, I need to focus this for you guys. Hold on here. There we go. This length here is going to be 7 inches. And then there's some missing information. We already have got x here. We're going to say this is y inches and this is z inches. And so your task is to find the value of x, find the value of y, and find the value of z. What I'd like all of you to do right now is pause this video and see how much of that you can get done on your own, and then press play once you're at a stopping point because either you're stuck or you're done, and go ahead and watch the video to see if you got it right. So most of this is actually all of this is pretty simple. A reminder that the circumscribed angle is supplementary to its corresponding central angle, which means this plus this has to equal 180. So I can write that equation, x plus 100 has to equal 180 because they're supplementary. So you could subtract 100 from both sides, but it isn't really necessary. X is equal to 80 degrees. So to find y, that's super simple. These are congruent. We have a kite here. So y is equal to 7 inches, and it's really not necessary to show any work there. And then the same thing here. This is z inches, this is 4 inches, this is the radius, and this is the radius. All radii in the same circle are exactly the same length. So z is equal to 4 inches. So at this point, we're done with notes, and what I'd like for you to do is draw a line at the bottom of your notes and write summary. So I'm going to be checking your summaries in kind of a different way in this unit. I've talked about it already, but in just a minute when you're done watching the video and you're done taking notes, you're going to get online and type in your summary and submit it, and you'll receive a grade for that. So I'm going to get you started here. The summary should always answer the essential question. So our essential question was, what are the key theorems about tangents to a circle? There are 2 that we talked about. So I would start by saying the 2 key theorems about tangents are, let me zoom out so you can see. The 2 key theorems about tangents are, and again, there were 2. And it's not enough to just list them. There is the tangent radius theorem. So you're going to write the tangent radius theorem says that, and then you get bonus points, not really, but I prefer if you write this theorem in your own words because that tells me that you really absorbed it and understood it. And then the second theorem, so you'll finish that sentence, and then the second theorem is the circumscribed angle theorem says that, ... And once again, you're going to state the theorem. If you want to just copy it, that's okay with me, but it's better if you are able to restate it in your own words. So get it written in your notes, and then when you're done, go ahead and click on the little link so that you can quickly type your summary in and submit that for a grade. And you're done. Good job.